So in the previous video we looked at logical consequence, and in this video we're going to look at logical equivalence. So let's go back to that initial equation that I showed you how to solve, and we introduced these arrows, these logical consequence arrows. So 3x plus 5 equals 7 implied that 3x is equal to 2, which then implies that x is equal to 2/3. However, if you start with x is equal to 2/3, then that implies that 3x is equal to 2, because you can multiply both sides by 3. So this implies this. So I could draw the arrow round the other way. And if 3x is equal to 2, I can add 5 to both sides, and I get 3x plus 5 equals 7. So that line implies that one as well. So I could draw the arrows pointing the other way. Okay, starting from there, I get to there, then there. Now, because they work in both directions, we could draw the arrows like this. So it has the pointy end at both ends, in other words. And this is logical equivalence. Okay, so we write A and then this arrow that points in both directions, B, okay? And what it means is that A, if and only if B. So that arrow means if and only if, and is sometimes abbreviated to IFF. Okay, what it means what it really means is that if, well, A implies B and B implies A. Okay, that's effectively what it means. So if A is true, then B is true, and if B is true, then A is true. So let's look at an example. For an integer n, so n is given to us as an integer, the two statements are n squared is odd and n is odd. So if n squared is odd, okay, if we had something like 49, then n would be 7, so n is odd. What else could we have? We could have 25. Okay, and n would be 5. So if n squared is odd, then n is odd. It makes sense to go from left to right. Now if n is odd, okay, starting from here, so like 3, then n squared is 9. N is 5, n squared is 25. So it works in that direction as well. And so there is an equivalence here, so a logical equivalence. So in other words, for an integer n, n squared is odd if and only if n is odd. Okay? That is the statement that we have. And that is logical equivalence.